Is about perpendicular and angle bisectors. The word bisect means to divide into two equal parts. Now you're looking at an isosceles triangle. An isosceles triangle has two equal sides. To indicate that the sides are equal, we will use a stroke. Just bear with me. We will use a stroke. So these two sides that have the green stroke are equal. These two sides are equal. At times we might use double stroke if the single stroke is already taken. All right, so usually we can bisect isosceles triangle. Let me write that word, isosceles triangle, because the two sides are equal. So if I have a bisector here, then I expect that this side will be equal to this side. Again, if I put a line here, then this side will be equal to this side. The triangles are not drawn to scale, so it will not look equal. So here I have a line, and the bisector theorem states that if you have a straight line and you have a bisector, then the distance from A to the bisector will be the same as B to the bisector. So let's label this point C. The perpendicular bisector theorem states that AC is equal to BC. Alright, so simply drawing a bisector on a straight line makes the two distance equal. The reverse or the converse of that is if you have an angle, let's say, and you draw a line AC and you bisect that angle. It means that these two distances will be equal and these two will also be equal. Alright, so this is a perpendicular bisector theorem and the converse of it. So let's look at an example. We are given this triangle MNL, and let's say that MN is equal to NL. So if NL is 2.5, that makes MN 2.5 based on the perpendicular bisector theorem. Also, if let's label this point P, if PL is 5 centimeters, then what will be the distance of MP? It will also be 5 centimeters. So once you have that perpendicular bisector, the two sides are equal. I'll ask this question: what is ML? So we know MP is 5. We know PL is also 5. So what is ML? Yeah, 5 plus 5, that gives us 10 centimeters. Good. All right, let's move on just a bit. Another example. We have the bisector. Let's label this triangle ABC, and then DB is the perpendicular bisector. So what do you know? Yes, AB is equal to CB. So can we find X knowing that AB is equal to BC? Yeah, we can do 3x plus 9 equals 7x minus 17. So we make the two equal to each other and then we solve for x. So we subtract 3x, basic algebra, we're left with 9. 7 subtract 3 gives us 4x minus 17. Then we add 17 to both sides, and we're left with 26 on this side. 4x. Divide by 4, divide by 4. And when you put that into your calculator, or you work that out, all right, so we cross those out, so we're left with x. And 4 into 26, we will get 6.5. Okay, so x is 6.5. Can we find BC? Okay, if x is 6.5, we're going to take BC, which is 7 times 6.5 minus 17. Okay, so this gives us 28.5. all right, so you use what you know to solve. Okay, here's another example, but in this case we're looking at the angle bisector. Again, it's the same idea. Bisect means to cut into two equal pieces, and we're bisecting an angle. So your angle is ABC. All right, and the rule states that if you have ABC and you have that angle bisector, then your distance from B to C is the same as C to D. So that angle bisector makes these 2 points equal. So if CD is 7.2, that means BC is also 7.2. Okay, let's look at another example. We have an angle bisector which is FK. Let's label this K. So FK is the angle bisector. Okay, let's say we have KG being 2x and EK being 4x minus 3. What will be the value of KG? So you do 4x minus 3 is equal to 2x. Then you add a 3 to both sides. So we're left with 4x equals 2x plus 3. Then we subtract 2x on both sides. So we have 2x is equal to 3, and x will be divided by 2. So x is equal to 1.5. All right. So we do 2 times 1.5 is equal to 3. All right. Now, if we have, and I want us to pay attention to this, if we have 3 perpendicular bisector, we have what is called a circumcenter. And if we have 3 angle bisector, we have what is being formed, the incenter. Let's look at an example. So remember, the circumcenter is 3 perpendicular bisector. My triangle is ABC. So if I do a perpendicular bisector of BC, all right, remember it bisects it. All right, so that's my perpendicular bisector of BC. Then I'm going to bisect AB. So I make sure it's the middle here. I bisect this AB. And finally, I am going to bisect AC. So that's the middle here. I bisect that. All right, so AC. So an interesting thing happens. Where the three perpendicular bisector meets, they would usually meet, is known as your circumcenter. So this point here is your circumcenter. All right. Similarly, if you bisect the angles of a triangle, so again A, B, C, I bisect angle B. All right, so the two angles are the same. I bisect angle A and I bisect angle C, then I have this center which intersects. That's my incenter. Let me just go back to my circumcenter. With your circumcenter, your vertices or your points are the same. So A, hold on. So we have, let's label this X. So AX is the same distance as CX, which is the same distance as BX. So this is key for you to remember. But when it comes to your incenter, I'm going to label X again, but I'm going to introduce Y, P, Z. So for your incenter, YX is equal to CX is equal to PX. Okay, so review this and we will do some more.